Now, this, remember, is a theorem. There's no set of sentences that's being placed before the single turnstile here, which tells you that this is derived from the empty set. So we're going to show that this can be derived from the empty set, which means that it's a theorem. This is one of the paradoxes of material implication, right? It says that if B is true, then for any A at all, A implies B. Now, we're going to draw out a bit of table here. Again, we'll need our usual 3 rows, and we'll just go with, I don't know, a dozen lines. I'm just sort of picking a number by more or less at random here. Okay. Now, since this is a theorem, we have no primary assumptions to start with here at all. So we don't have anything to write into the first line of the first line of this table. So the only way that we can start this derivation is by working bottom up. So we're going to need to write this in at the very bottom like this. We can't put in the line number because this is going to be the last line of the derivation, and we have no idea how long this is going to be. So how can we infer this line? Well, the only possibility here is going to be conditional introduction. I mean, there are other rules that you could use to derive a conditional. But conditional introduction is, well, I guess there are two that you could use that don't require you to have anything else previously in your derivation. And of them, the only one that's going to be useful here, I mean, one possibility would be negation elimination. But negation elimination is not a very useful way of deriving a conditional. The only one that's going to be useful here is going to be conditional introduction. So we write that rule over here in the justifications column because that's the rule that we're going to use to get this. We will introduce a new column for a subderivation, and we'll write in what we would need for the subderivation that would allow us to infer this by conditional introduction. So we have to have a subderivation that goes from the antecedent to the consequent. So it's going to have to start with B. That will be our line 1. This is going to be labeled assumption for conditional introduction. And then the subderivation will end with if A, then B. And no line number, and we don't know how we're going to get this yet. So we have this so far. Now we can look down here. This is our new goal sentence. So how would we infer this sentence? This is another conditional, and conditional introduction is a good way of getting conditionals. So we can try setting up to use that again. So we're going to get this by conditional introduction. So we will need another subderivation. This one is going to run from A, from the antecedent, to the consequent, which is B. I'm going to shrink these columns down a little bit. They do not need to be as wide as they are. So we've got this. Now, how are we going to get um, from A to B here? Well, here, right, we're at the point right now where we can actually join up the top and bottom of the derivation, right? We have B up here. This was an assumption that we made. And then we can get B down here just by reiteration. So we just label that line 3, and we got it by one reiteration. Now we can just fill in the rest of the line numbers. So we're acquiring this here by this subderivation. And let's put in the scope line for it right now. So here is our scope line. This runs from lines 2 to 3. Um, this one here is 5. It that subderivation goes from lines 1 to 4. We'll put in this scope line. Um, and yeah, then everything, all the line numbers have been filled in, and then all we need to do is just delete this blank space here that we don't need. And there we go. We have a completed derivation here. Um, and so you can see with this one, right? Like we did everything here, bottom up. I mean, every line that we entered in, we entered in bottom up. The only thing that we did top down was writing in justifications and line numbers. Like that was all. And that's sort of extreme, but it illustrates the way that SD really works. Like you do virtually everything bottom up. And this is the single biggest mistake that logic students make when they're working derivations, is they try to go top down, and that's the exact opposite of the way that the system actually works. You do almost everything bottom up, like you're working backwards almost the entire way, and very little you do top down. I mean, even with this one, for example, I mean, you see here, right? We did almost everything. We only did 2 lines top down, and one of those we never actually used, right? It would have actually been the derivation would have actually been shorter if we'd started going bottom up from the very beginning and gotten to the point where we just had the goal sentence of C, started thinking about how we were going to get C, realized, well, if we pull A, if A, then C out of this conjunction, and then do conditional elimination, then we would have recognized you never actually are going to need to get this out of the conjunction, and we never would have needed line 3. And we would have ended up with a derivation that was 1 line shorter.